Hey everybody, well, I couldn't stream live tonight. I had some internet issues, so I figured I would set up a little recording here of myself working on this project for tonight. Fortunately, I won't be able to chat with any of you live, but I figured this is a little bit better than nothing, and we can kind of walk through some of the stuff that I set up in advance, sorry, and just work through that, see exactly kind of what I did and where I'm going, and hopefully, we'll get somewhere interesting by the end of the evening. So, I'm still gonna just kind of treat this as if it's live, and you'll just get to sit along with me as I figure this stuff out. And unfortunately, like I said, won't be able to chat, but hopefully your Mardini submissions went well if you were able to do them. If not, hopefully you're just enjoying this after the fact. So, all right, well, let's dive in. So what I decided to do, since it was a Softbody thing, was I was like, well, let's do some gummy worms. So I decided to make a gummy worm. So let me dive in here and we'll take a look at what exactly I made. So first of all, I had to make, a couple different really simple things. One of the simple things I made was just a line with a bunch of divisions in it, which I then swept. I created a backbone here with the grid. And the grid has a couple poly bevels here to just kind of round these edges. So I rounded these top two edges first, 0.2 and 3 up here. So if we look at that, we got 2 and 3 that get poly beveled. And then here we're going to bevel 0 and 1, I believe. Yep. And those have a much tighter radius. Just fused together some of the points that were kind of floating out there for some reason. It might have just been that they were close and didn't get fused properly. Not really sure exactly why. I also resampled it at this point because I figured it would make sense to have it be a little bit more uniform. That way it's not, there's not big gaps here or anything like that. It's kind of nice and even all the way around. I figured that would probably help with the soft body effect as opposed to having it at this stage where there's these kind of big areas where there's nothing. I just kind of assumed that would be the best thing to do, and then just match sized it up so that it was sitting right on the plane. I'm really liking this match size node. I was using the transform node a lot more before to get things to sit on the ground, but I'm really liking this match size node. I don't know why I didn't know about that before, but it is great. I think it's a little newer, so I'll blame it on that. But anyways, here's the line that I created. Oh, you know what? I'm realizing I'm in my dual screen mode, so my apologies. There's no way that you can see some of these other things, so let me just pop this back over here. Give me 1 second. I will reload my setup. There we go. I wasn't even thinking, unfortunately, about that. So here we are, Gummy Worm inside. Looking back at it here. Was there anything that we missed? No. Points 2 and 3, fusing, resample. No, should be all good. So here's the quick curve UV. This is a AE-lib tool, just a really fast way to do curve U attributes on these things instead of doing resamples or anything like that. I just dropped this on. It's got some nice, attributes and things like that lets you do. So I use this one a lot, but obviously you could use a resample as well. And then I used a point fop to create some ramps here. Ramps from using the curve U attribute as the U input here. I set the frequency up quite a bit because I wanted it to kind of like these little bumps in it, like a gummy worm would have. I then fit it, instead of being between 0 and 1, I fit it between 0.8 and 1. Use the smooth to kind of make it not so linear, give it a little bit of fall off. And then I put that into the p-scale attribute because I knew that when I went down to the sweep here, it would respect that p-scale attribute. So now I've got this sort of gummy worm. It kind of almost looks like a waffle French fry as well, but whatever. It's my gummy worm. When I shade it and make it gummy looking, it will not look like a French fry anymore, or at least not at all like a French fry, I hope. Here you can see, whoa, let me jump inside of there real quick. Here you can see the cross section that I used. It's nice and flat at the bottom, so that's gonna kind of give it that gummy feel. It's kind of rounded at the top, flattens out at the bottom a little bit. So that is hopefully going to give me that sort of feel for the way that candy's made. I used a smooth points. This is a QLib point node, but you could use the other one. This one just had a couple more options that I was going to play around with, and you can really go pretty crazy in here, but not going to do that. So turn on, I'm just going to use the topology pass. I think I brought the iterations actually down. I believe by default they're at 20. So I brought these down to 5 just to keep it a little bit closer. And yeah, that just kind of gives it a little bit of, smooth it out a little bit, a little more of that candy feeling, hopefully. Use the match size again to center it to the origin. And then down here, I was trying out a couple things. I was trying to see what kind of what resolution would work the best for these simulations. So I went ahead and made an out that's like the high quality one, and then I poly reduced it and made an out proxy just in case like this would be a better system to use. I used the Vellum pack only because I knew that this would put that into 2 different streams here. Now, for me, it isn't geometry and constraints, it's high quality and proxy, but in reality it's packing and naming it. Like if you go inside of here, it's simply just packing and naming it more or less. I mean, there's some stuff here that might happen, like there's some other stuff in here as well, but I mean, there's really not a lot going on. There's a couple rename nodes or naming nodes in here as well, but I mean, pretty straightforward. It's not even using this stream here. Looks like these aren't. Well, that won't matter. So it's not using this. It's not. Yeah, it's literally coming in here, not doing anything, coming down. Yeah, so it's not doing anything almost at all, other than packing, naming, and putting them together, and just outputting them in one stream. So I could actually use any of these packs for that. I could use an RBD pack if I wanted to, but that is 3 nodes, so it kind of doesn't make a ton of sense. Now there's some cool things here. There's some display flags and things like that you can set on that one. These are obviously tools that were created for different reasons. Obviously the Groom pack is going to be different, but anyways, Vellum pack had 2 options, so I was like, well, let me just do that. I know that nothing much is happening inside of here other than just combining them together. And what I could then do is take this out packed, bring it over into my setup here. Now it is creating tetrahedra because this is again using the tet node. So, and I just changed everything up the stream. So here, when I take my actually this should be in packed, should be named, but you can see it's out packed. So then when I do this Vellum unpacked, I have the option to take either one of these at this point. The other thing that's really nice about this as well is that if I wanted to do anything to both those constraints and the geometry that I created, I could do them there. I could transform them in one stream here. So if I move them up or do whatever, that will respect both of those pieces and it'll move both of them together. So anyways, this is just kind of a quick way for me to be able to kind of switch back and forth and do stuff upstream of that unpack if needed, like if I wanted to move it up or, do whatever. So I was kind of not totally sure how I exactly was going to do this in here. So this I'm still playing with. So I was just, doing this to screw around in here. Like I said earlier, I got these geometries kind of created, and then I'm going to go from there. So the other thing I figured I'd want is like maybe like a plate. I was thinking like all these like gummy worms like falling on like a huge pile of them falling on a plate. I only started working with like a small amount of them at first, but I just made a quick plate, nothing too crazy. Just did a circle, fused the endpoints, did a polyfill because I actually was finding that the circle itself was like actually giving me some really weird things to then when I wanted to edge divide, it wasn't like creating loops nicely. I don't know if I just missed something or if I had something set wrong. I had it set with, I think it was the sliced arc, and that was acting weird. There was a couple different things that acted weird, but anyways, that wasn't working. So I went this way, did a couple point groups and to save the unshared edges. And I actually then noticed as I kind of came through this that I did like a soft transform here to kind of curve it up. And then I realized that there was some really strange stuff happening. And I actually had this other like primitive in here that got created. I don't really know. So I just like, you don't even see it change, but there's like a primitive, I guess, around the outside here. I don't know. I was doing it quick maybe and just messed something up, had something set improperly. But anyways, set a fuse just to make sure that everything was all cleaned up, because when I deleted that one, I was like, well, I don't know what I did there exactly. Used the Labs Thicken, which is wonderful. And obviously it just, thickens it down a little bit. Use the match size just to lay it right back down on that grid. And then poly beveled the edges just a little bit here. And I had them set with the ignore flat edges because, and set this up to about 45 because these are obviously like 90-degree angles here. So I only wanted to bevel those. I could have set loop selections, but this is nice. I don't have to have like any baked in selections. I can just tell it, if I up any resolutions or whatnot in here, that it would respect those edges. So anyways, that's the plate that I created. I could create some, silverware next to it or a glass or something. I don't know. Maybe I'll do that if I have time. But for right now, I just was figuring, this will be fun. Do something like this and go from there. So this I should actually change the name for because it's not the setup for it. I was going to set it up and then maybe sim it in a different node, but really it just ended up starting to get simmed in here. So let's just walk through what this all does. Down here. So first of all, this is the tet conform node. This tet conform and the Vellum tetrahedral. These two get created when you do the configure tetrahedral soft body. So when you do that, puts both of these nodes down. This node is looking for the polygon mesh, and this is additional points and curves in this second part of it. So the idea here, or at least my best understanding of this, I guess I'm not going to say that I completely understand why these tetrahedrals are being created or they exist or whatnot. But if we look at it in wireframe, we can hopefully see a little bit better what's going on here. So this might be hard to see on the stream a little bit. I wonder if I could make this any easier to visualize. Let's see. Is there these groups maybe? No, that doesn't help us. Edges, no. Primitives, no, we don't have any groups there. That is unfortunate. Anyways, I was just looking to see if there's anything at all here that would help me kind of explain that a little bit better. What if I do the wireframe ghost? Does that make it harder, easier to see? Maybe harder. But I guess we can just do this and kind of jump inside here and look at them inside. So obviously the outside of it remains basically the same. I don't think anything changes there. Maybe a little bit here as far as these outside shapes maybe change. Oh, no, I'm sorry. My apologies. I'm just looking at the high quality. So if I put a null down here, for example, and take a look at that, that's the same geometry as that. So there is no difference there. Maybe there's a couple little changes that this node makes, like here, maybe just to clean up a couple things that it doesn't like. But for the most part, it's the same, similar outside geometry. It doesn't change a whole lot, except for obviously triangulating them. So that's actually what we're seeing. Sorry, it's triangulating it. So that's what it does. Triangulates the outside. Inside, though, is kind of a whole nother matter. And this is a lot different than what you might see when you're looking at oh man, it's just so hard to visualize because there's so many little lines in here. But basically what it's doing is creating these like little triangular like shapes inside of the mesh that are the, I guess down here maybe we can see as best. There's these triangular shapes that are being created all in here. And you can adjust that with this max tet scale. So the size of my object here is 0.15 long, 0.01 wide, 0.01 tall. So, the max tet scale, I would want to be, at that 0.01. That is allowing them to be a little bit, maybe a little smaller than they would be. The default here is 0.1, I want to say, and this should change this quite a bit. Let's see. So this is 39,000 primitives. Let's take a look at what happens when we do this. It's gonna check everything. So 7,000, 39,000. Let's see where this goes to. Yep. So 17, 100,000. So obviously, making the tets smaller And that's probably these edge lengths here that is creating. I'm assuming, let me just double check here. I see. So this is actually the volume of the tetrahedra. So I believe then that the smaller that the tetrahedral will be, the more flexible and things it might end up getting to. So we can maybe test that real quick in a second here. So I'm just going to set it, I'll set it down a little bit. Now, obviously, I'm guessing that if I set this to 1, this is going to sim way quicker. I'm guessing, because there's way less points and everything. And kind of at its heart, Vellum works with points and does all its stuff with points and primitives for constraints. So the less of those it has to calculate, obviously, the better. So the Vellum tetrahedral I messed with a little bit. I changed the mass to set uniform just because I felt like maybe the scale, I was making it real world scale. So I think that was maybe messing with us a little bit. To start with, actually can set this back to defaults because I'm not really sure even what these models do. But anyways, so this is obviously set to tetrahedral stretch and preserve volume. There's a couple damping ratios here. I upped the stiffness quite a bit because it was lower and it really needed more stiffness. It was kind of flattening out pretty easily. And then what I did here is I put 2 nulls because we're going to reference those in a second. This allowed me to then pack one more time, transform up those 2 things, unpack it, and that's kind of our first bit of geometry that gets sent into this Vellum solver down here, which really doesn't have too much going on with it as far as anything that I've really changed here. I think I turned sleeping on just so that as they piled up there wouldn't be anything that changed. And I think really the only major thing I changed was the time scale, just because when you have these small little simulations like this, sometimes the time scale actually feels too fast. I mean, technically is like realistic, quote unquote, with like how fast it falls, but we want it to look good. So I just reduced the time scale a little bit and it seemed to work quite a bit better. So then over here, I was doing a thing where I wanted to instance these gummy worms on points. So I added a point up here, using the add node and just moved it up 0.5. Used a point jitter to move it around with scale. Updated the seed because that'll allow it to actually change every frame. Used an attribute randomize to randomize the n value. So you can see here that's going to jump all over the place, and that's going to, that's going to be used to iterate this worm in that direction, basically. I believe that's the X, or that's the Z direction for the copy when you use the normal like that. I also added some point velocity just to push it down a little bit so it didn't start with no velocity and have to pick up speed. It was just feeling like it took too long for them to fall. So I was just giving them a little push down. And then this is a QLib node, and it's literally just an on-off switch for this whole chain, which is wonderful because it's, again, a really simple thing inside here. It's this, I like this null named Nope. But it's literally just to switch inputs on that input string right here, this. So that's really all it is. It's just an on-off switch, and it just is something super simple that you might do pretty often. Set up a null, set up a switch, all that kind of stuff. You just literally put down this switch off node. There's another, I think switch if is sort of similar, but you do have to set some more nodes up and stuff. This is just super clean. It's right in line, and you can see right here that it's just going to switch off. So these are my instance points, and what I was doing in the switch off, I guess I should talk about real quick, was I was doing a modulo on the float, or on the frame value. And so what that's doing basically is returning the remainder of the frame if you were dividing it by 3, I believe. So it's giving you the remainder of that that function. And basically what that does is every 3 frames, for example, it's going to have a 0 remainder because it's going to divide evenly. So, I guess I should say on frame 3, it's going to, on frame 6, it's going to, right? So we can look and see, okay, now I have in here, don't go before frame 6. So then the next one should be frame 9. So let's look at that. And sure enough, it's on, and you can see it up there. So frame 9, frame 12, so on and so forth. Um, the other thing, so what you could do then is you could change it to 4, then it'll be multiples of 4, 5 multiples of 5, so on, so on, so on. Anyways, and these double ands just basically mean that both of these have to be true. So it has to meet this and that. And when those both are seen as true, then the input will be set to 1, and that'll be it's just Boolean operators basically. So anyways, those are my instance points, and what I do with those is put them inside of this Vellum solve. Stop. No, don't solve. Please stop. Thank you. Turn off. In here, I have this Vellum source. This is instancing on points, and I have the worm SimWorm Geo, SimWorm Con for constraints, and the SimWorm instance points all set into these different fields basically. And those are these nodes right here that I created, and basically it's looking at those and instancing those to the points. So that's why I did this whole thing at origin, because then it gets instanced onto that point. So you can just watch real quick what happens here. You'll see it gets instanced up there, and then they start to fall. So let's actually, this is going to sim pretty quick. So let's take a look at what this looks like. I'm not really sure how well this will work, but here we go. We're now into the unknown here. So let's see what happens. And wouldn't it be so funny if this just sims way better? It looks like they're collapsing a little too much maybe, but to be actual, yeah, they're like definitely too floppy. But they're actually fairly stable. Interesting. So yeah, I would actually have thought that that in this case you might have had more stiff geometry because you had less tetrahedrals inside of it. But for whatever reason, it seems to actually be less stiff with less tetrahedrals. I think it would, triangles are strong. I would think that would give it more rigidity, but I guess not. Kind of strange. A little surprised by that, but Houdini does that to you sometimes. So let's just look at what this looks like here as it's falling down. They're definitely way too floppy, but starting to get kind of interesting. Now, the thing that is really nice here is that this is seemingly quite a bit faster than what I had before. At least it feels like it. So maybe I will leave it on this as far as like it's as far as the number of tetrahedrals in it. And maybe I just go back here and we'll adjust some of these. So this is where we're going to adjust all of our stiffness attributes and things like that. So let's take a look at this mass here. Let's see where that's at right now. So let's go to points. This is where obviously all of the attributes are saved for your Vellum simulation. So we got our P scale here, obviously really small because you've got the thickness set here, and it's a small object. So tiny P scale. So let's see the mass. I have it set to 0.05. Let me actually look back down here and see what's happening, because maybe these are actually getting crunched too much. Actually don't seem like they're getting... So we kind of have to determine whether these are getting smushed by the ones on top of them or if they're just too flimsy overall. And to me, it kind of feels like they're just too flimsy overall. Like, it doesn't really feel like the top ones are squishing them too much. Like, they are, but again, they're just not holding up to any weight above them. Not that the ones above them are too heavy. So let's try this. I'm not going to mess with the mass. I don't think they're too heavy. So let's just to see what happens, let's kick this up to 10 in the stiffness. Gummy worms are pretty stiff by their nature. So let's see where this goes. The other thing we could do is use our damping ratio, and that'll take out some of the energy from our system here. That's really what that's for. So if we feel like things are springing back too much, maybe, or there's just too much stuff moving around, we could use our damping ratio, and that'll really lower the energy that's in our entire sim. Nah, this still feels a little weird to me. Let's take a look. Oops. Let's take a look at these. Take a look at these constraints coming out of here and see um what's going on. Actually, what's happening? Why is it not showing me the constraints? That's the Vellum geometry. This is the collision geometry. This is the constraint geometry. Maybe because they're tetrahedrons, it won't show me the constraints separately because they're technically all connected. That's probably what it is. This is showing me the constraints. It just can't really show it any differently because it's all one unit. That's probably what's happening here. So I just wanted to see what was happening inside of them, but alas. All right, let's try this. Let's go to 0.5. See if that gets us a better setup here. Let's do that. I actually don't think that even updated because I don't think anything. Yeah, there we go. That updated. So let's just try this. Let's go to 0.02. See where that gets us. No, nothing too crazy there. I just want to kind of find that middle ground a little bit. And so this is a little bit of a strange thing just from me thinking about it because it's a volumetric and not a like strictly edge-based or length-based attribute that's happening here with this tet scale. So it's just a little different to think about it that way because you're setting a volumetric attribute that's close to the length of the side, but not quite. They're not quite coupled. So just interesting. Kind of strange. Anyways, let's take a look at these. See how these look. I'm hoping these are a little bit more solid, I guess I should say. A little bit more rigid. Seem a little better. I kind of just have to figure out the mix between what quality of sim versus the versus the look that we're getting from them. Like does it look right? Does it what's the time length? The time frame for these to sim out? All those kind of things. And actually, you know what? It's fine. It's looking okay, but I'm just going to go back to the setting I had before. It was working out pretty well. I had it set to 0.15. I had this, wait for this. This takes a little longer to cook. Obviously, it's making quite a bit more prims and points. And it'll take a little longer to sim, but it's fine. I'm not really overly worried about it. Let me set that back to 1, and let's just take a look at this. See what happens here. Probably just flip book this, honestly. Just do that. Where's the plate? There's the plate. Let me set up a camera here and make sure I have that set. Find the plate here. Great. Unlock that. And now I did discover that some of these things, actually I think it's if you show the guide geometry can sometimes slow this down a little bit. So I am just templating this object merge in with the plate. So that way I can see it without having to have it calculate that maybe every frame. All right, start up the flip book. There we go. It's like, where is it? Let's play this back and see what's. That is quite a big bounce there for a Gummy Worm. Boom. Yeah, the funny thing is this is at half speed, so like it's just funny. You wouldn't think of these being this being slow, but this is half of the speed that they should actually be falling at because they're only falling, a little bit. They're pretty small, they're just little tiny things. So if you drop them, they drop pretty quick. So I think that's always a tricky thing in anything, simulation, computer graphics related, is that the way that you see things and experience the world is so different than the way that you would in film, basically, or in any type of media. So I think that really changes your perspective on, like, gravity and what that actually feels like and looks like in a simulation. Like, it is, things are drastically different. And to be fair, like, even if you talk about something, I'll just chat while this is going here. Even if you talk about something like an explosion, for example, in the film industry, they have to really plus up explosions. Like, explosions by nature are not these huge, grandiose things most of the time. I mean, there are times when they are, but for the most part, smaller explosions aren't really spectacular. So they have to add gasoline and diesel and all these things to it to really make it this have this visceral reaction rather than just this pop and done. So anyways, all that to say, sometimes you have to really bend physics to be able to get a nice result. And that sometimes for people that are very technical, myself included, that feels really counterintuitive, because you're like, no, I want to make it exactly like reality. I want to make it the speed exactly what I would expect it to. But really in full speed, sometimes these things, like if you actually dropped a bunch of gummy worms on a plate, it's really not going to look that interesting, in reality. Like, in slow motion, it might look pretty cool, but so that's kind of the way you have to think sometimes with these things. So just some thoughts, nothing too definitive, but just things that I think about a lot when I'm setting up sims and things like that. So yeah, these are still too bouncy, unfortunately. All right, let's kill that. And let's go back up here to this tetrahedral. Could possibly set the mass a little lower, but let me just really crank this stiffness and see where that gets us. Because maybe that's really what we're needing here. So let me make a new flip book and let's go. So then if this works and gets us a much nicer result, what I might do is try again to reduce that conform, and from there, actually, hopefully it'll sim a little faster even. I mean, this isn't slow. I mean, it's probably going to take a few minutes it would probably take like 10-15 minutes to sim a 10-second clip, which I'm really not anticipating on doing. But yeah, this only takes, a few minutes to get a decent chunk of this done. So let's see what this looks like. It'd just be so funny if this actually isn't doing anything. So this is the nice thing about mplay, is that we can go to our sequence list here, and if you haven't used this before, you should start, because you can use the compare images, and we can look at these two. You can see this one's templated, this one's the live one, and we can use our compare image right here to go back and forth. And sure, there's a small difference there, but really not much. So we need to see what we should be changing here, because this is changing, but not by much. So let's look at this. We'll use this frame here, since I think we should be stop. And stop. There we go. All right, that should halt this render. There we go. All right, so let's look at what we got going on here. So you can see right there's my wipe back and forth, and gosh, there's really very little difference. In fact, it's even hard to tell which one's which. So the top, the old one is on the right and the new one is on the left. So I mean, barely any change. So we got to really figure that out. Let's see. So in this scenario here, stretch is our this is really our main our main part of this here. The stiffness and all this stuff, and then our mass and thickness up here. So let me just look at this again, see if there's anything here that I should be looking at more. I don't really see anything that sticks out to me, at least. I mean, maybe I'm missing something, but well, you know what? When in doubt, let's try. I have a feeling that maybe a substep might help. So let me do this. Let me set this max tet scale back to what it was by default, which was 0.1. It's going to recook that. Going to give us some new geometry here. Let's go down to our solver. Let's go to solver tab. Let's add a substep in and see what that gives us, right? Because that should hopefully give us something. If it's not, then I think we got an issue. But all right, let's put this back on like that. I think that's how we had it. All right, take 3. So again, this little sequence list allows you to look at these different things. So if you don't want to be using the compare, you can turn that off right there now. And now we could just flip back and forth between the two. Yep. Yep, we're definitely getting somewhere a little bit nicer. So it's a little bit of substeps. It's a little bit of maybe the stiffness of it. You know, it's going to be, we're going to have to play with these things a little bit here. How does that look? Yeah, I want that a little stiffer still. Maybe some more constraint iterations will help with that as well. So let's play this back, see where we're at. Yeah, see, they're not bouncing quite as much now, but they are smushier, and that's probably that tet scale. All right, well, we're just going to kind of keep jumping back and forth here to see where we can land. Let's try this. See what this does with two constraints. So this actually, sorry, that's right. That one wasn't much. So let's do 0.1. We'll go back to the high quality one. Two substeps. So another thing we could actually be doing here, just to think about, you know, if you were doing this in a real situation and not just kind of, you know, not flying by the seat of your pants, but just kind of, you know, trying to get something out as quick as possible. If you wanted to set something up for a studio setup, using tops would probably be your best bet here, because you can use the wedging concept in that and wedge your different parameters here. So we could set those tets to be at a different level on multiple passes through this solver. We could have it do stiffness at different levels and sim those all out. Now, we don't have time to do that tonight. That's really more something that you would do in an overnight render, for example. You know, when you're leaving the studio at night or something, just let that go and come back the next day, see what you got. But in a scenario like this, it really would actually be super helpful, because we could then start to dial in some of these attributes and have a lot of, you know, I wouldn't have to run a sim, change the values, run a sim, change the values. It would do it itself, you know, in kind of in rapid succession, or sometimes even in parallel, which can be nice. Now, this sim probably wouldn't parallelize. Is that a word? Wouldn't run in parallel probably too well. If we look right here at, like, you know, my CPU, that's not really a great view to look at because there's just boxes everywhere. But you can see here, we're running about, you know, 50% of my CPU, for example, and I'm using quite a bit of my GPU. Let's see. Oh, actually, let me just look at what's happening here. Yeah. So just to give you an idea of what these things mean, if you're not super savvy on these things, you know, every so often it's using almost my entire CPU to simulate this. Most of the time it's using a couple threads here really heavily. And then it's also using the CUDA, which is the which basically is saying the OpenCL part of this, the GPU acceleration part of Vellum, is being used right there. So, I mean, there's some overhead there. There's some overhead on the CPU, but for the most part, maybe you'd see gains on like two instances of this maybe running at the same time in a TOPS network. But in this scenario, probably not a huge increase to do a whole bunch of them versus selecting them individually and going through them. So let's see what's happening here. Oh, I made a flipbook intentionally. What am I doing? That's what I want to watch. Looking pretty good. They do definitely deform quite a bit. Just look at this. Like, see this one here. This is really bugging me. I don't love this. I'll let this finish. I must have gone one frame too far. All right, let's look at this. Let's look at what's happening here. This is way too flexible. All right. So it's got to be that the mass is too high. So let's adjust that. Let's half it. See if that gets us anywhere better. Back to our camera so we can compare nicely. Do it again. All right, so let's compare what these are looking like. Put this one on here. We can kind of just scrub back and forth. Absolutely no difference. None whatsoever. Cool. That is an odd one. Not sure why that didn't do anything. All right. Well, instead of that, let's just try really pumping up the stiffness on that and see where that gets us. I mean, this has got to do something. It doesn't. I don't know. I don't know what's happening. Maybe we just need to keep upping those substeps, constraint iterations. That might be part of it. Yeah, that doesn't even seem different at all. Let's take a look here. Yeah, there's literally no difference there. So it must just be that we're not pumping in enough constraints, constraint iterations and substeps to actually have this converge. So all right, let's go back here. Let's try to do this a little quicker because we realize that we're going to need substeps, and this is not what's causing our issue there. This isn't causing our issue either. I think we had this at 1 when I started. So actually, let's set it to, I don't know, 100. Sounds good. All right, so let's up the constraint iterations. Let's just double them. It's kind of going to be maybe a little crazy, but let's see what happens there. New sequence and go. So unfortunately, here we have to do 200 solves on each frame. So this is definitely like if you start upping these, like this is going to get costly for your sim, but it'll help it converge. So, to a more stable, configuration hopefully. So let's see what happens here. I'm going to turn this off and just let this kind of roll through. Let's turn on the compare and see what we got going on here. Oh, I see. That flip book probably doesn't even have an image there. All right, let's look at this one. I think our left is the one that we're looking for here. Yep, you can see that there's actually quite a bit more stiffness going on in there. If you look, yeah, yeah. Oh, I'm sorry. I'm trying to see which one this even is. Sometimes it's hard to tell. Oh, the left one was the new one. Let's take a look here. Let's turn it off for a second. Hmm. I mean, I don't hate it. It just doesn't feel particularly like Gummy Worms. It definitely has a fun feel to it, but um, still feels a little too soft. Maybe it feels too floppy. Oh, geez. There's one that totally goes bananas right there. Oh, that's so weird. What the heck does that do? That is so strange. All right, let's try another substep in here. See if we can't get something to work. Um, just make sure I'm not leaving anything else out of here. All right, run it again. Again. So if you haven't joined me before on one of the actual live Hangout nights, usually I will stream on Tuesday nights. With it being Mardini, I am doing quite a few more streams. Next week, I probably will be doing a bunch again, just because those are some interesting nodes for me as well. There's a lot of lab nodes that they've got, um, planned up for that. I believe, let me pull up while this is simming. I'll just bring this over here. So it looks like next week there's going to be some interesting ones: box cutter, lot subdivision, tree tools, lightning generator, the cable generator. What is it? Sci-fi panels and the mesh tiler. I definitely have used a couple of those before. I've used the tree tools before, and those are really interesting. I haven't used the cable generator, and I'm really interested to use that. Um, and some of these other subdivision things could be kind of neat too. So yeah, we'll see. Not too sure about kin effects. I do really like it. I've messed around with it a little bit, but as far as like creating something from scratch with that, I don't know. I have to think about that. But luckily, I got another week or so before we have to jump into that. Solaris is interesting too. I'm really not sure what to do for that. So that one's kind of been perplexing me. I've done stuff in Solaris, but it's never been anything that's like, artistically amazing or interesting to look at. So I'd always be happy to do a tutorial maybe on how to use some of those things, from what I've learned so far. But um, yeah, anyways, that is next week. So if you haven't joined us before on one of the live hangouts when my internet isn't giving me a fit, yeah, hopefully you can join us next week. Keep an eye out for Twitter. Um, my uh, my handle on Twitter is Houdini Hangout. My personal one is Peter Kubik. And yeah, if you want to check me out, follow those, and you'll be able to know when exactly we're going live. All right, let's see what we got going on here. We definitely have a different sim. That is without a doubt. And I believe the left one is, yeah, that's the new one. So we definitely have a lot more solid simulation going on here. So let's take a look at this here and see what. Yeah, I feel like that's like a little bit more interesting to me. Like that is feeling a little like it's squishing a little more than I maybe would like it, but I like that it's at least bouncing back to some sort of like, you know, some sort of more stable flat thing like that. It's not just staying like totally tweaked and squished and stuff. You know, where there's stuff covering it, you know, we will see it. This feels a little too loose. Let's see this. Let's see that one fall here. I think that looks better. Let me double check. Cuz this, yeah, that one was really doing some weird stuff previously. I don't know which one it was. I think it was this one. Let's look back here. Yeah, that was like tweaking really weird. Yeah, that's feeling pretty good. All right. All right. I think that's going to be our parameters for the sim. Now, the one thing I'm thinking is let's have it actually have, you know, drop some more on there basically. So what I'm going to do is um adjust where these are getting instanced on because I want this pile to be bigger. You know, it doesn't feel like a huge pile yet. I'd like it to feel like a pretty substantial pile. Now, how many I can simulate in time, that's a different question. But I'd like it to be a more substantial pile. So, what I could do for this, and I think I'm going to, is actually turn these back down. Now, this isn't going to break. Oh, wow, not 10. 100, please. This is not going to break the simulation. It's just going to go quite a bit faster. You know, like it's just really going to resolve quite a bit quicker. Everything should be falling at the same time, and they'll be starting to pile up in places, but they're just going to do some really goofy stuff that I don't really want it to be doing. It's going to be getting, like I said, smushed and twisted and all weird stuff happening to it. So, this will just sim way faster, way faster. So I'm going to use that, and let's talk about these points up here. Let's figure out what we could do here. So I've got these instance points popping up every so often. So I could make them go more often. So let's first try that and see where that gets us. But I'm guessing it's not going to get us all the way there. So let's do this every other. Man, that feels like that's going to be way too many, but not way too many, but you're gonna see they're probably gonna intersect. So let's take a look at what happens here. So I'm guessing these are gonna overlap at some point, and it looks like they did there. Maybe no, actually not. All right, let's keep going. See when this breaks. Might not. Maybe we'll be fine, but I have a feeling this is gonna do something real weird at some point here. You can see that crazy noodly thing going on down there. Now that is not certainly what I wanted to do, but that's just a sub-step thing. I'm pretty confident of at this point. I guess we could do every other. It doesn't really feel like any like the biggest thing I was worried about there was an interpenetration when they get spawned, but I don't see that happening. So that's positive at least. Um, what I think I'm going to do is have it slowly. I'm gonna stop this. Let me just double check and make sure nothing has interpenetrated. Oh, yeah, that is interpenetrated technically. All right. So let's not do that because that's just setting us up for weird collisions and stuff from the start. So let's go back. Let's set this to 3. Instead, let's see if we can add some more points into this. So what if I added 2 points in here? Set this to 0.5 as well. So now we've got these 2 points flying around here like crazy. Instead of it just being 0.1, let's do like 0.2, right? Really move them around. And this is going to allow them to jitter all over the place. What I could do here is, let me think. To reference this, I could do a copy to points just to see what these are going to look like. So these are my target points. This is my geo. Let's just see what happens here. Yeah, cool. So this is going to source in 2 at a time for these. Those are fine. It's just kind of... Actually, these are surprisingly seeming fine. So let's just get crazy. Let's get real crazy. Let's add in a 3rd point here. See if we can't just totally go hog wild with this. Let's see. Definitely see. Oh no, I guess not. Go through. Yeah. Yep. There we go. So what we could do though, since these points are like that, let's see if we can't do a relax. Point relax. It's not. Oh yeah, it doesn't like the P. It has no P scale. So let's give them a P scale. Let's make a P scale float. And let's give it a value. Geez, probably not too much. Let's try. Oh, that's not even a value. Let's try 0.1. See where that gets us. Now it has a P scale. Now it's a little happier. Let's see if we can't push these apart. Now you'll see that nothing's happening here, right? So the reason for that is that we need to do the relax in 3D space. That will then move these apart, right? So we can then adjust these. So let's revert this to default. And now let's take a look at these and see where they get us. Oh, yes. But therein lies the rub. We have tiny little things now because it is actually using that. Well, it's using that on this copy to point, but I'm guessing it's also going to be using that later on as well. So let's do an attribute delete here because we just want to use that for the relax. We don't want to be scaling anything there. I broke that whole chain, so let's connect that in properly. Select them all, hold down A, drag down. That'll just align them nicely. So now right here, we'll have it remove that P scale attribute because we only need it for a short bit. There we go. And let's just play with this a little bit, see if we can't push this. Let's maybe do half of that. So this is just a multiplier on the P scale that we have already, which is 0.1. So that just kind of gets us in the ballpark, and then we can go from there and see where these actually go. And now these should all, for the most part, get pushed apart a pretty good amount. Now, granted, they could come in contact if they're in the right direction, right? But now we have this kind of built-in safety net that is going to keep these apart. So like when I push this up here, yeah, that one like jumped out of the way a little bit. So I really could go maybe even a little crazier with this than I'm thinking. And these are going to jump around quite a bit. So let's see where these line up in relationship to this plate. So let's do this. We'll look at them from above. And you know what? Let's actually do our 4 views and let's look at it from the top here. Some of them are getting pretty wide. Let's see if we can't take the point jitter. Maybe that's too much. Maybe we'll do 0.15 and then let them still push apart, and then they'll stay more in the center, but they'll kind of jitter around a little bit. I mean, it could be fun if they fall off the edge of the plate. I guess that won't be the worst. All right, so we're still instancing points from here, but this is just kind of a visualizer, so we can have this, you know, to see, you know, what's going on. Still using these instant points here, so that's actually doesn't really matter. Let's go back over here. We're just going to have the first one drop in like normal. Go to single view. Set this to camera 1. Let's play through it. See where we go. And it actually instanced those kind of quicker than that first one. So that first uh, the first object of that's wave in the front. That's funny. Yeah, that's kind of fun, hanging off the edge there. Oh, see, that is unfortunately what I was really worried about right there. I'm going to just stop this for a second and go back. You can see here, there is why we want to avoid those inner penetrations, because they're just going to get stuck together like that. Oh, that's too bad. All right, might have tried a little too hard with this, so let's just go back a little here. Now, another thing we could do as well, instead of doing it this way and setting it up like this, just as I'm thinking about it, is we can go up here, we could move this add up, we could do a duplicate, which is a pretty simple conceptual node. It's basically just going to make copies. Now, this is a copy and transform. There's a couple, there's other things that would, there's a couple other copy nodes that do similar things, but this one is just going to duplicate it in place. So from this standpoint, if we look at it, we're going from having 2 points here. Now you can see right there 2 points, and is just obviously as we go up here, we can have a whole bunch of points all in the same exact location as that original one. So the total number is 1, 2, 3. Let's do 4. So this might just be an easier thing because we can dial it up and down. So let's actually look at these. Sorry, let me find the frame where those get created. Let's see. There they are. You know what actually might be causing a little bit of our issue here, now that I'm actually thinking about it, could be this. So let's actually change this to 4. We'll have it every 4 frames and see where that gets us, because it could actually just be that there's so many of them that they're not able to get out of the way of the group previously. So let's take a look at this and see what happens here. In fact, I am going to look at this and just come back up so I can watch from a little bit of a different angle here, just to see what's going on. And there you could see exactly what I was saying, where those were getting sourced basically on top of that previous bunch, more or less. But now I think we're doing okay. Now I think it's looking fine. We're giving it enough time to start to get most of those out of the way, so there probably won't be any real, overlaps there. And they're all falling at the same speed, more or less, so they should, they're all starting with like velocity moving, so they shouldn't like bunch into each other. You know what I mean? Like they shouldn't like back up into each other almost. More of them have gone over the edge than I was kind of anticipating. Let's look at the M play here. Oh, that stinks. I actually wrote over this previous one, but that's okay. Sometimes that's something that'll happen. If you don't hit this little button up here, unfortunately, it usually will just by default keep overwriting the same viewer, basically the same timeline or the same sequence that you have. So that's a little unfortunate, but let's take a look at what we get here. We're definitely getting a lot more, a lot quicker. So that's nice. We're definitely getting a much bigger plate of them real quick. So yeah, that's looking pretty good. But I am going to take a quick break and I will be back very shortly. So might edit this out, might just leave it. And while this is going, but I'm going to go take a break. All right, everybody. We are back. I didn't have my headphones on. Um, yeah, so we got some gummy worms falling on a plate here. Really crazy one there at the real end. Kind of went nuts. Not sure what exactly happened there. Now that I'm seeing it. Oh yeah. Oh yeah. We've got some crazy constraints there, but that's all right. Hopefully that'll be a little better um with our higher substeps and everything. All right. Well, let us go for it. I guess it's time to start to really get Sorry, my brain just stopped for working for a second there. We just need to cash this out, basically. So I was looking for words that were not needed. All right, so let's just do a file cache. Um, we can do a fancy Vellum IO type thing, but I don't think we really need to worry about that this time. So let's. I just want to see what's going on exactly here. And as I'm thinking about this, I'm pretty sure that this is the lower resolution geometry, which I really was kind of gonna switch it out, but at this point, I was gonna have it, do something where I switched it out at the end, but at this point, it's getting a little down to the wire. So I wonder if I can't just do this. Give it a second to calculate. Real geometry. Let's just see how this works. Out of curiosity. Yeah, it doesn't even seem like it's longer, really. I mean, it's definitely not faster, but it doesn't seem to be taking any longer. So I guess I should just use the final geometry. Yeah, those collisions are going to take a little longer, though, aren't they? Completely collapsed. It looks so funny. All right. I think it seems like we're going okay. So let's just up this. Let's maybe not go as high with that. We'll go 3 substeps, 150 constraint iterations. Let's see. Actually, flip book this. No reason not to, I guess. Excuse me. All right. Guess we're going with the proxy level geometry for our final. Oh, well. It is all in an evening anyways, so there's not a whole lot we can do about this, just gotta go with it. All right, we'll set it back to where we were before. We know that that will work. Let's go to file cache here. And these new file cache nodes are fantastic because I can do this in the background nice and reliably and keep on working on other stuff right in Houdini. And I don't even have to keep track of that crazy, what was it called? I can't even think what it was called. The, yep, there's a name for it. Well, there was a little like render manager thing that would come up and was kind of a pain, honestly, to use. I don't know where it is. Huh. Oh, scheduler. Here, this thing. So you'd have to have this thing up to see what was going in the background. Now we'll just see it right here, and it'll be a little top style sequence. All right, so let's rename this. We'll call this, call it worm file cache. That'll be fun. So I'm going to get rid of the hip name. I don't really feel like it's that necessary to be in the whole string. We can look here and see where it's saving it. It's saving it out to worm pile cache v1, worm pile cache v1, frame, all that stuff. So putting, a longer thing in this base name just feels so crazy to me. So like if I do hip name .os, right? I mean, it just gets so long. You know what I mean? Like that is like significantly longer naming string. And instead of putting it in the geo, let's put it in the sim folder. We have version 1. That's fine. This is going to be a time-dependent cache. It will be frame range. Let's not do 240. I think that's going to be a little silly. So let's go down here and change this to 120. That'll update's great. It is a simulation, it is a frame range. There's one substep. There's one global substep. There are 3 substeps on this. So we don't want to substep the frames and save fractional frames, basically. So we're not going to substep it. Yeah, I think that's it. Let me just hit save in my project. And then let's save to disk in background. That will load up this lovely little top visualizer here. And this should be frame 120 right there. And so these are all of our simulation frames. Now you see there's a little exclamation mark, but really all this is saying is unable to read blah, 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 because it hasn't been created yet because we just started. So don't worry, it will load it, and it'll load it as soon as that frame hits right there. So now if we come back to it, boom, little error is gone. So now this is going to just churn away in the background, which is super, super nice because now we can go do whatever else we want to. And, we've got some computer resources free here. It's not a ton, but let's look. Yeah, there's some free resources there that we can use. So let's go for it. One last thing I want to say about the file cache node, and I'm going to say this every time now that I use it because it is something that's slightly surprising to me, but should be known. If you go into the advanced and into the save, there is a thing that's checked by default, which makes sense when you think about it, but it is a little bit surprising when you aren't thinking about it. So this says harden base name on save. So basically what this is saying is when this is checked and you hit the save, any of the save options, it takes it from this being $OS, or $hip name $OS to an actual hardened name, meaning it is hard coded in here now. So just be mindful of that because there could be times where you save this out and then copy and paste it, right? And you could be thinking, oh, this is going to do $OS each time. So, okay, drop it over here, make a whole bunch of different options, that you're saving out. And actually what it'll do if you hit save the first time and ran that once just to make sure it was working, it has now saved that and it will actually write over that on each time. So, and as Houdini is great and it's wonderful the way that they have it set up where it will do what you ask it to. But unfortunately, what you're asking it to do then is write over your files, possibly multiple times on multiple streams, and you'll only have one of your results at the end and it won't even be named properly. So just make sure you pay attention to that when you're saving this, because sometimes you'll be in a hurry and do that, and it won't work right. But anyways, let's see where we're at, because we can just scrub in here now, and there they come in. There's our worms. They're coming down. This is the other really nice thing about this, is that we have our display flag just on this node, right? And there's really not a whole lot that we need to do to like make sure that this keeps updating. It is doing everything it needs to in the background. It is just chugging away, doing its thing, keeping itself going. It's kind of, rolling with two different files here, probably saving one, rendering the next, or getting the next one ready type thing. It just really, this is a great node. Always use these as much as you can, especially with the tops. It's great. All right, so we've got our sim worms here. Let's start getting this ready to go to render. We'll probably notice a little bit of lagginess here, possibly. Hopefully the recording will be fine. I don't see any frames dropping or anything. So let's make a couple render nodes. So we'll call this render worms. We'll make one that's geo. Render plate. Red makes them go fast. Render fast. That was a joke that I heard from Steve Nipping, who does Applied Houdini. And it's a good dad joke, so I gotta say it because I'm of dad age. All right. So render plate. What else do we need? Let's do a grid. Use that for our ground plane. I am just literally gonna put it right in there. I'm not gonna even get too crazy here. So we'll call this render ground. And red. All right, let's start loading these in. So we're gonna do an object merge. This will be, what are we in here? The worms? Yeah, worms. All right, sim worms. We don't have an out for that yet, actually. So we can leave this open and actually jump up here, go down here, and I'm gonna do a null. You can do outputs, you can do nulls. They both are technically fine. Nulls are a little more flexible, but outputs are a little more rigid in how they work. An output will always output to whatever, will always be the output of whatever node you're doing, as long as you have it set to the output. A null is just, you have to have it set to that flag or whatever for it to be a render output or a display output, things like that. So I'm just going to call this out sim, just so I know what is happening here. Color it green. I did see that jump over there, which means I should have my out sim. Yep, there it is. Now that I'm thinking of it, I should actually not have my inputs be capitalized because it actually messes this up. The caps will all, well, I'm not going to do it now because it's simming and I don't want to screw anything up, but yeah, I should do that for the future. Out sim, there it is, accept. So what I should do is like in sim geo like that and not capitalize it, because then it won't be up at the top of my hierarchy. Great. I'm just going to copy and paste this because I'm more or less going to do the same thing here. Just do this. Go to the plate. Oh, nope. Geo plate. Out. There it is. In plate geo. And then here's the ground. I'm going to do a UV project because I'm pretty sure I want UVs on these. So let's, that was a funny way of saying that. UVs on these. All right, let's take the size down, maybe to 5. You can see that that's actually not moving with it because it is just projecting orthogonally. I'm just going to initialize it to best fit. It's pretty straightforward. It's a plane. Great. Normals. Let's add those to all of these to make sure we're good there. There's normals. I'm going to do a null for the render just to, note that that's where the renders are coming out. Sometimes I'll set those as purple because those are that's what the flag is. Like if you set a purple flag, if you control click on this, that's your render flag. So In that case, purple tells me that it's a render flag. Whatever. I might just be a little weird, so you can color things as you choose, but that just helps me personally. Do a render there. Same thing here. The SimGeo. Let's hit space G and that'll jump us in here. What do we got for this? Do we have UVs? We do. That's cool. Not that I think we'll use them, but good to know. Do we have normals? We don't have normals. Let's add those. Don't know why we don't have normals, actually. I should have made some normals before, but in any rate, at any rate, in any rate, that's not the right phrase. At any rate. All right, add some vertice normals there. Great. Let's do the ground as well. All right, we already set that to normals. The plate, let me do this. No. I don't think I'm going to UV it because I think I'm just going to make it like a solid color of some sort. Let's do no. Render. I think this is crunching away now. So hopefully it won't drop too many frames, but there could be a little bit of lagginess here. So my apologies if you see that happening while these worms are doing their thing in the background. All right. Looking cool. Let's see, how far are we? About halfway through. That's great. Again, that is a nice benefit of having this sim, rolling in the background, because got all that stuff set up in the time that it took for, basically half of that sim to roll through. So can't complain about that. That's pretty nice. That I think moving around my viewer like that, it is not happy. So I'm sorry if any frames drop here. My apologies. Also, be warned, this does seem to be fairly memory intensive. I am currently using 64 roughly gigs of RAM. So just be mindful if you're doing anything like this. Now, granted, some of that is being taken in the fact that this is actually loading a secondary Houdini in the background. So that's part of it as well. But yeah, just be mindful of that. Friends don't let friends do crazy things in Houdini. So, right. So we got this all set up. I'm really hoping nothing freaks out here. Ooh, that is messy looking. What is that? That's a crazy little thing going on there. If that gets evened out in the next frame. Not really, huh? Look at that. That's okay. Worse things have happened, I suppose. The other thing that might happen too is if something gets really goofed up here, I might just stop the render at a certain point, like only render to frame 72, for example. Like if it does that weird, like stretchy kind of nonsense that it did before. So we'll see. All right, how to render this? Well, I'm in a daily build, so I don't have Redshift loaded right now. So let's just do Solaris again. Do a little Karma render. That is not. Don't type Solaris. Type Lop. Lop. I just usually call this Solaris. This over here, and we will go inside of it. This is going to be a totally different thing now. So let's do a scene import. We're not going to have any materials per se, so let's just do a regular scene import. We'll set that up kind of from scratch because we want to specify what objects. I'm going to do pattern here, star render star. Those are just wildcards saying anything that's called render, bring those in. I also want to make sure I bring in let's see, star render star, and I'll do star cam star. to bring in that as well. So now I have, let me set this up here. Pane tab, Solaris, scene graph tree. So now I have my camera and those geometries there. Great. Looking good. So that's my import. Let's think of what we need. So we're going to need to set up some shaders, some lighting. Yeah. Well, let's set up the shaders first, I guess. We'll do a material library. What materials, what type of shaders should I use? It's kind of some flexibility here, but let's do a material X because that's kind of nice, and I think that's going to become very popular across a lot of different renderers over time. So, and I get kind of a little more familiar with material X, right? I'm just going to move this out because this is like a way that you can set up all like different things, and I can do standard surface instead. Put that here, and I'm going to, twirl these up because I don't need to have all those things open like that. I can always have them connect as needed. I need to connect something to it, but there we go. There's a standard surface going into surface output. If we need a displacement, we'll put it here. Let's go up. So now I know this is a standard surface material X. So I'm going to call this one, I'm thinking this is like a table. So let's just call this table. Make another one, alt drag. We'll call this one plate. We'll call this one worms. We got, that's just reminding me of Dumb and Dumber. And if you haven't seen that yet, that means you're probably a lot younger than me because everybody I know has seen that. So anyways, all right, I got worms. It's a line from that. All right, material library. We've got those set. That should be bringing our materials in here, which is good. We've got the plate, table, worms. This wildcard right here is making sure it's making those material VOPs visible in this scope right here. And in fact, I'm just realizing that I actually want to put my geo into a scope as well. So I'm going to do geo. So that's going to put those both into their own scopes here. So we've got all of our geo in there, and we've got all our materials in there. So that is looking good. Actually, now that I'm thinking of this, I'm going to take the cam out of here because I might want that in a separate context. So scene import there. I'm going to bring this over here. We're going to call this one, instead of render, we're going to call this cam. And instead of geo, we're going to call this cam like that. Then we can just shift click both of these, alt click to get a merge. And then I'm just going to hit L to rearrange that. So now I'm just merging in those two things. We have camera and geo. Let me see if there is anything here. Oh, I don't want to import materials on either of these. Get rid of that, get rid of that. Just checking to make sure I'm not missing anything here. Nope, looks good. I normally don't want these to be in an X form, but it's just quicker. This little thing just looks a little messier to me to like have these little transform things in here when you can have these scope. Those are a little more clean, but whatever. I'm not gonna belabor the issue. So let's do an assign material. Drop that down. We're gonna do 3 material assignments, right? So 2, 3. So let's open up our geo. I'm just gonna drop that down because that's for collections and stuff. So we don't have any collections set. So we're not gonna be using that right now. So this will be easier. So we'll do ground to table. I called it 2 different things, so that's a little confusing. Let's do the plate next. Plate to plate, and then worms to worms. So this is just making these links. There's actually 2 different ways you can do this. This one I feel like is actually a little bit, makes a little more sense and is a little quicker. There's one that's more like visual. That is a, I think that's called a linker. Yeah, material linker. So this one has a totally different view like this, where it will show you them like this, and then you do like plate. Yeah, see, like it's a little strange. Like you do plate, table worms. And if we like, then depending on your yeah, see, it's filtered based on selection, so that's a little strange. I mean, here you could do it this way and like open up your geo and say the ground is going to go to the table, the plate is going to go to the plate, the worms are going to go to the worms. So like, I guess it's fast enough that way too. And really, there should be more or less no difference between these two. This one just feels a little more like solid to me. Like this one with this filter based on selection checked and you're like clicking on stuff. Like if you have it set this way, it's like, okay, there's no links here. Oh, wait, I have to look here. Oh, if I look there, it'll show all of them. You know, so it just sometimes to me this feels a little like that being on by default maybe is what the problem is. You know, when you have 3 materials, it feels a little clunky. Maybe if you had 1,000, be better. But anyways, this one's fine. I'm gonna use it. And let's assign, yeah, let's put a karma node in here. And what else should we do? Let's just do like a dome light, I guess. That'll be easy enough. Definitely tell it's doing stuff in the background because it's crunching away. I can, my mouse kind of glitches every so often. Kind of feels like it's like dragging. Let's see where we're at actually with this simulation. Great, we're at 87 frames. Let's see if we got any craziness going on. If we do, I might just stop it and just let it be. 72. Let's jump to 80. See if we got anything weird going on. Ooh, that does look like there's some yeah, looked like there was some intersection, but I don't see any like explosive stuff going on here. 88, I think. Yeah. Oh, maybe that just finished. Might have. It's looking pretty fun. Got a bunch of crazy worm things going on here. Kind of interesting. You know what? I'm just wondering if I did or not. Oh no, I do have auto sleep on. Perfect. Just wanted to make sure that some of these would stop being calculated and kind of be left in the background at some point. That would be good. Great. Well, that's still going. Kind of a nice little benefit that we can go in here and do this whole thing. So let's look through cam 1 here. What I'm also going to set is this in here so that that's ready to go. All right, I guess let's just take a look at it, see what it does. Let's switch over to Karma. This is just Karma CPU so that it doesn't freak out my my renderer over here. Okay, so what I'm going to need to do is actually adjust some camera settings because obviously you can tell that it is focusing improperly, which is ridiculous. So let's do that. Let's do camera edit up here. I'm going to set this back to Mardini GL. See if Shift F will work or not. No, that one is not working, unfortunately. What we could maybe do is bring this down here. We look at it at this point. F. Yeah, so that should show us the focus plane. It doesn't really look like it is. I'm going to hold down Shift and left click and see if I can. Oh yeah, that did set the focus. Cool. I can see the focus is right here. I don't know why the focus plane isn't showing up, but that's okay. No big deal. Yeah, you can see that this definitely is setting our focus there, which is great. So now if I come down here and do Karma, hopefully, no. Hopefully it won't change the focus distance. Oh, it changed it. It's just not set to set or create, which now it is. Let's set or create these here. Shutter open, set or create, f-stop, exposure. We'll set all these. F-stop is crazy low. Maybe that's actually the problem now that I'm thinking of it. Is really the f-stop is maybe too small. All right, let's try this again. Shift F. Odd. Well, let's go here. Let's move out of that viewport and to the side here and see where this focus distance is. Oh, there's our problem. I didn't select the camera. I just dropped it in there, like assuming that it knew what camera I wanted it to adjust. So if I drop this in here, now it knows. No, now it's not ignoring me because I am actually telling it to do something, and that's what. Now I've noticed this recently, and I don't know if that must just be because it's coming in from SOPs. There's like some weird thing that's going on there. I'm not really sure. Looks like if we adjust some of these things in here, this will this will actually do what we want it to. So maybe I'll just adjust some of these aperture things. Um, that should be good. Um, Great. That looks pretty good. This way we could, sort of set how wide we want our viewer to be, all that kind of stuff. So let's set it, maybe right at 50. Be good. Cool. So now if we look at that focus distance, we should have that. And if I do shift and click here, we're in business. Wonderful. So now if I move this focus distance around, you can see that it is in fact doing what I want it to, which is lovely. So if we f-stop way down, that's obviously going to blur out our stuff. So let's do it to 1 maybe. I mean, that's a crazy low f-stop, but just see where that gets us. I'm also going to turn off the plane. Oh, that's right. There's a couple different modes for it. So there's one that's just a line. There's one that's actually like a solid area. And then there's one where it's off. So there we go. Actually, you know what? No, we're going to set this a little higher. Maybe 1. Oh, that's focus distance. No wonder it freaked out. 1.4. Then we'll get just a little fuzzy at the edge here. Great. That's looking nice. All right. Let's just go to our karma settings here. Make sure that's on default. Render settings. Great. It's actually pretty quick. That's a 12-second render. I mean, granted, there's nothing much happening there, but it's fairly fast. Let's go back up and see how our sim's doing. It's getting there. It is getting there. What are we at, 98? We have 19 more frames to go. So we're getting close. All right, let's go back into Solaris. And let's mess with some of these materials. So for the plate, first of all, oh, you know what? Let's set an HDRI first because this is just so flat. We're not going to see anything here. So let's go to, let's see. What about any of these? Forgot that they even had these as defaults. No, I don't actually like that at all. What about this? No, I don't want that either. That's so bright. What's happening? All right, I'm going to go back to my little resources folder here. Oh, do I have? I think I have something interesting. Let's see what these are like. It's kind of fun looking. Give it some interesting lighting, right? Sunrise. Looks pretty cool. In fact, that's actually 2 out of focus. So I'm going to bring this up to like 2.2. Great. All right. Now we've got something going on here. Let's go to our plate again. Standard surface. All right. So specular. Let's turn the specular roughness down because actually, you know what? Let's leave it like that. Let's take a coat and let's add a coat to it. I think that'll be a lot better. Let's make the coat roughness like 0.05 so it's nice and reflective like that. You can see that there's some specular stuff going on there. We got this nice shiny reflection. Great. I think that's it. Kind of an off-white colored plate. Not really thinking too much on that one. The worms. Let's see what we can do with these worms. So let's do transmission. I think we're going to want to go all the way up with that. I want to turn the base off. Specular. Let's do a little more rough on the specular because those aren't super glossy. They're kind of more matte. I mean, they definitely, actually, yeah, let's even go further with it, 0.4. Interesting. Some interesting looking things happening already. All right, transmission. Let's see here. What can we do with these different controls? Not really seeing a lot of change in this scatter parameter here. I'm not sure where that's tied into exactly. Let's see if we do like something like that. No. Just wonder. Okay. Set that. This should definitely color it. Yep. Sure does. Let's see if we can't scatter something else here. Is there anything else that we can get happening? Interesting. Version should be almost like diamond, so I don't think we want that. I'm just seeing if anything will kind of trigger anything else here. Don't really see a whole lot going on. All right, let's just reset this back. We'll just use the color, and we're gonna randomize the color of these objects. So let's see here. Can we do this strictly in here? I'm looking for a 3D representation of, or I'm sorry, not a 3D representation, but a representation of the geometry that's coming in. Basically, like which primitive is coming in, you know, like which number primitive are each of these. So let's see here. Geometric. It's too bad. Let's see what this is real quick. don't think that's what we want. The nice thing is here in, first of all, I am going to stop karma because it is acting real slow. So let's do that. Where are worms? They are. What happened? They just didn't load properly. That is a weird thing. I've never seen that happen before. Might just be a bug. Oh, we're so close. So close. Should be pretty fun. All right, so let's just look here again. So I'm gonna do Solaris scene graph details. This will allow us to look at the scene graph tree in more detail, basically. So let's look at render worms first, the component, and see what's on here. So these are, let's see if there's anything ID wise. Don't see anything here that's giving me any ID. What's one about here? Mesh 0. Let's look at this. Oh, look at that. Yeah, I should clean those up. That's too many variables coming in anyways. No good. No good. We don't want them. All right. So what I can do is I can set these. See, all these prim vars that are coming in are all from the geometry that was set. So they're all importing those prim vars. So let's go back here. Let's go back up. Let's go over to the worms. Let's clean this up because we got way too many attributes. So let's just do an attribute delete. You should often do this for, you know, when you're getting to render or export things or whatever, just save on memory and, you know, keep the things that you need and the other things that you don't. So get rid of the things you don't. So PV we need. Let's see what else. Gosh, probably not much else. P scale, not really going to use that. No, that's good. Vertex attributes, normals. Great. UV. Yes, please. Don't need those. Don't need those. So the interesting thing is this is actually updating this without even really being able to see that. It is like kind of flowing into this. So let's go back up here. Let's go into there. Let's just see. Yeah. Should have. Oh, that's interesting. It does not seem to have updated those, which I am slightly surprised by. All right, let's see if I kill this, bring it back, if that'll reduce it. No. All right, let's go in here. Let's make sure that we're importing the attributes that we want. There we go. Can I reload this? Well, I mean, it's not the end of the world, I guess, if these all come in, but oh, gotta delete non-selected. There's my problem. That's why there looks like there's too many of them still. Because there were too many of them. Now there's way less. Sometimes it's a simple checkbox, right? I don't even need that on. It seems to be importing them regardless. Great. So now we have those. The other thing I'm going to do is I'm going to set One more thing here. Let's do it. Oops. Let's set a connectivity. This will be a nice, easy way to do this, I think. We'll do as primitive attribute. So this will set connectivity for all of these primitives and set a class attribute. So each primitive now will have its own class, and I can use that as like a seed number to randomize some colors and things like that. So at least that's my plan. All right, great. Now we've got that. Let's go back into Solaris, take a look at the material library. Okay, well, first of all, let's look at this, make sure it's got what we want it to have. It has class right there. Perfect. Just perfect. All right. Material library, worms. Let's do material X. Let's try this. Geometry property value. Oh, I just heard my computer kind of roll down, like the fans all kind of stop. Yeah, there we go. Got the whole thing. Awesome. There's a lot of primitives in there, aren't there? Yeah. There sure are. Look at how many. We got 4 or 5 million in there. That's what we want. All the primitives. Okay. Back to this. Oh, that's why you can't see them, because the transparency's on. That makes more sense. Sometimes the obvious is the correct answer. Let's see if this works. Class. Let's see. Need a ramp. Let's see if there's a ramp in here. Color ramp. Perfect. Oh, right. You know what? That's actually not how I want to do that, because now that I'm thinking of that, that's creating a bunch of indexes. Sorry, integer values, and that's just not, that ain't gonna work. So let's do a float, attribute adjust float. This will give us random, minimum maximum value. Perfect. Instead of calling this p scale, we'll just call this random value, like that. That will flow into here. We should have a random value now. We sure do. So let's go in here again, there. Let's do this primvar reader. For some reason, I feel like this is going to work better, because this says primvar. So let's just go with it. Variable name, random value. Let's do a ramp. Color ramp. Great. So this random number will look up something on this ramp here. Let's set it to something very noticeable, like infrared, like that. Let's do out, transmission. Let's do transmission color. We can open that up if we want to, just to see that that's working. Transmission color is now grayed out. Let's go into our camera. See if it worked. Oh, too bad. It did not work. Spoiler alert. Oh, you know what it might be? Might have worked. It just might have been that every primitive is. Yep. Didn't work the way I wanted to, because what I'm doing here is setting it per point. Um, yeah, that's not what I want either. Okay. Here's what we're going to do instead. We're going to do both. Sometimes you just aren't thinking straight. I can do it as a point attribute. That's fine because this is going to be adjusting point attributes. So now here we have this. We're going to randomize it by custom attribute. The custom attribute is going to be this class. If we visualize that, the random value, there we go, looking good. Those look like those are all solid colors between those. They're not. So if I turned this to element number, it's a random mess like that. If we turn it to custom number, the whole thing is now randomized like that. So cool. We have a random value from 0 to 1 that's based on the entire connected geometry. Hopefully that made sense. Let's go back here and take a look at this. Here we go. That's what we want. Is that so hard? It wasn't that hard, but it was definitely harder than it should have been, I feel like. All right, let's look at this material library here. Look at our ramp. And unfortunately, it just seems like we're getting a lot of these color. Let's try something like this black body. So the nice thing about doing this in here is that we are going to actually have this value is going to be in here quickly accessible to us rather than going out back into the into our object context, into our standard SOPs context. So this can all just live in Solaris and not have to be referencing geometry back and forth. So yeah, that's, to me, that's the benefit here. So I don't know, we could just pick a crazy random. Oh, that's all purple. Those are going to be all blue. Burno, that's fun. It was the same. Just playing around here. Oh, interesting. I don't know. The black body's kind of fun. Makes me feel like something cool is happening there. All right, and then the last thing I'm going to do is I'm going to see if I can find some sort of interesting table, maybe tablecloth. Hey, there we go. Look at that. Looked on Polyhaven here, and what did I find? A tablecloth. All right, let's do. Oof, what do I want to do? I guess it's going to be an 8K, I guess. Not sure what those are, but I'm going to grab all of them. Yeah. All right, let's download this. Put it in my resources, textures, fabric. Oh, 5. Wonder what that is. Oh, this one. That's kind of fun. But this is more of a. This is more of something that would be like a food picnic kind of thing. So why not? Um. All right. Let's see if that's downloaded. Actually, it sure is. Show in the folder. I'm going to unzip that. Zip. Great. Let's go into the table. Let's do some stuff here. Textures, fabric. 7. This. No. We're gonna preview or not? Okay. That's detailed. All right. Let's try that one. Base color. Second to load that in. Way too big. All right, let me zoom out here and just see if this is just an issue of, yeah, just an issue of the plane being gigantic compared to that. So, let's see if I can do this. I think I saw a tiled one. Let me see if I can do that and tile it. See how this one works. Maybe this will let me specify how many tiles I want. Yeah. Yeah, I think that's what I want. Sure. Base color. And we're going to do file. Yeah. Here we go. Oh, that's really nice, actually. Let's look at cam 1 here. Yeah, that looks great. That'll work. That'll do. All right, so we've got this first one. This one is, just call this diffuse. This input's out of the way so we don't accidentally copy that over. In fact, I think I'm just going to check to make sure. I think that's going to be sRGB. Do the same thing here. For this one, what else do we need? We need the roughness. Let's do that. The roughness. Cool. Normals. Actually guessing that this is going to be let's call that linear. I'm not sure. What other things are in here? Just want to see what these other image things are. We have roughness, normals, AO. I'm not sure what ARM is. That's a new one for me. Oh, look at this. We got different colors. Well, we got to try those. See which one we like best. Color 1, color 2. Which one do we like? It's getting too blue here with that. Let's see what this one's looking like. I think this one's green. So I'm guessing I'm going to like the red one the best. They're so classic, the red. It's not bad. I don't hate the green, but I feel like the red is just so classic. And also, I feel like some of these stand out better against the. Oh, I'm going to turn off. I'm going to turn off the. Nope, that's the wrong one. That object highlighting. That'll just look nicer. We don't have that crazy highlight going on. Yeah, I think I'm going to go with the red. Yeah, it just feels classic, you know? Let me see if I can't get some motion blur in here. I'm also going to, I think, put a little bit of a transform in here, a little this is an append. What will this do? Yeah, perfect. Oh, that's great. I want to do just like a little push, maybe like a little pull out or something like that. So I can have this. Yep, perfect. So I'm going to have this start like that. Then we'll have it go out 0. 0.2. So just give it a little bit of movement. Kind of interesting. I will have to adjust where those focus distances are. So let's see here. Do that. Shift F twice. Let's shift. Go to sampling here. Shift set it like right about there maybe. Yep. So set that. Come down here. I want this to be set right about in the middle again, I think. So let's do it. Oh, I'm not in the camera. That'll explain it. All right. Shift, not Alt, Shift. There we go. Great. So now those focuses should be relatively in the center. Let's just double check in the middle here. Perfect. Looking great. Might move a little bit, but nothing too bad. Great. Let's check motion blur. Let's see if I can get any motion blur on these guys. Should be able to see the motion blur there. All right, Shift F. Let's look in Karma here. Enable depth of field, project motion blur. Let's see if we can do velocity blur. Will that bring in our velocity blur? Let's thinking. Is it ever thinking? Doesn't really seem like it's getting the velocity blur on it. Interesting. Not sure why that's not working. I would think that that would work. It seems blurry. It doesn't seem like we're getting any motion blur. All right, I'm going to kill that. I don't know. Not sure why that's happening like that, but it does seem to be. All right, well, I am pretty much at a point where I'm just going to be setting this thing up to render. So I think that's where we will end our recording here tonight. Hopefully you were able to get something out of this. Sorry again that I wasn't able to do this live, just due to my internet being a little flaky. But yeah, hopefully you enjoyed seeing this walkthrough. And yeah, hopefully you can catch me next time, probably sometime next week, with some of the lab nodes. So yeah, well, thanks for watching if you've gotten this far. And yeah, hopefully I'll see you soon on the channel. Thanks so much.